In this video, I want to highlight some differences between reading isolated single words and reading word sequences. Reading individual words, also called discrete word reading, isolated word reading, or single word reading, is measured by response latency. That is, a word is shown on the screen, and we measure the time from the point that the word appeared to the point that the person starts to utter the word, or to the point that the word is finished, that the sound is completed. This is measured in a unit of time, for example, thousandths of a second or milliseconds, but can be converted to a rate so that it is equivalent to some sort of metric like words per minute. But what we're measuring is one response to one word. In contrast to that, reading tests tend to use word lists. So what we can measure with word lists is word list fluency, or also called word reading efficiency. And people typically have to read words that are presented in columns. And these words aren't related to one another. They do not form any sentences. People just have to read them one after the other. And the metric we get from these tests, as you know, are words per minute by counting the number of words that are correctly read. So we do not include incorrectly read words. How many of those can be read within 1 minute? The same kind of test can also be done with actual texts. So here a narrative starts like a story, the person has to read it, and we count how many correct words per minute are read. Again, we get a fluency metric in this sort, and these tests are called passage reading fluency or oral reading fluency. So these are three different kinds of tests. The first one concerned isolated single words, and the other two concern word sequences. Let's look at some data that highlight some of the differences between these two kinds of tasks. Here you can see data from 3 grades, grade 1, left column, grade 3, middle column, and grade 5, right column. As they read isolated single words, so discrete words, on the bottom, and word lists, so serial words, top row. Each panel shows a group of children, so each little circle or point here is one child. On the horizontal axis, we see the accuracy in the task, and on the vertical axis, we see the speed converted to words per second, so everything is comparable. So one would be 1 word per second on average. Let's start with the lower left panel. These are data from the English language because that makes it easier to see the trends, because English is difficult enough that children are not very accurate for a while. But exactly the same pattern is obtained in other languages where it has been measured, except the accuracies are higher. So the important pattern to look at here is in first grade, children who are not yet very accurate, so below 80% accurate or so. They are also slow, so none of these children are fast. Children who are more accurate than 80% are increasingly faster, so those who are most accurate are also the fastest, up here. Remember, this concerns isolated words, so children respond to individual words shown on the screen. In grade 3, there aren't any inaccurate children. Almost every child is above 80% correct, and everyone is a bit faster than they were in first grade, of course. And then in grade 5, they're another bit faster also. This is higher than this, and also a bit more accurate. Everyone is 90% or better. So what we see for reading individual words or discrete word reading is that once some level of accuracy has been reached, at least 80% or so, speed can begin to increase, and then speed increases slowly with grades as children become more efficient readers. Now let's look at the top row, starting again at grade 1. Again, we see that for those who aren't yet very accurate, speed is relatively low and is in fact about the same as for the discrete words. So while you're not very accurate, your speed in reading word lists is about the same as your speed reading individual words. Then for those who are more accurate, we see that speed is higher, increasingly higher. And in third grade, everyone is more accurate, of course, and faster. And the important thing to note here is, first, there is a much greater range of speed in reading word lists than in reading isolated words. And the increase in speed from first to third grade in reading word lists is much greater than the increase in speed between these grades in reading isolated words. And this is quite obvious for grade 5 as well. So what this means is that becoming faster with word sequences goes well beyond becoming faster with individual words after you are sufficiently accurate and fast with individual words. So reading sequences efficiently must involve more than reading individual words efficiently. One relevant observation here is that serial rapid naming tasks correlate with reading fluency. So RAN, as serial naming is called, especially of letters and digits, is known to correlate with word list fluency and passage fluency moderately to strongly, both when the two are measured at the same time and when RAN is measured very early, for example, in kindergarten or first grade, and fluency is measured several years later. It turns out that RAN measured in the beginning of first grade can predict reading fluency in grade 8. And these kinds of relationships have been very consistent across languages and ages where they have been measured. Now, here is a very impressive finding that also holds across languages as far as we know. After grade 3, if you want to predict a child's word reading fluency, it is more informative to know this child's performance in RAN, that is, in naming sequences of digits, rather than to know the child's performance in reading individual words. So RAN becomes more highly correlated with word list reading fluency than isolated word reading speed is. In contrast, discrete naming of digits does not predict reading fluency very well. This suggests very strongly that something that is common in rapid serial naming tasks and reading fluency tasks is very important for determining how fluently someone reads. And what this seems to be in common is the fact that both involve the processing of sequences of things that have to be processed one after the other with some overlap. Let us now take into account some observations that we have seen from considering eye movements in reading. What is different between reading a single word and reading a sequence of words or a sentence? The first thing is preview. When you have a sequence of words, you can begin to process the upcoming word before you actually turn to look at it, because attention is to some extent decoupled from gaze, so you can switch your attention to the next word before you jump to fixate on it. So preview is one difference between single and multiple word reading. The second important difference is buffering. Buffering means temporal storage, and here we're talking about the eye voice span. So when you're reading aloud, your eye looks well ahead of the voice. That is, you're looking at a word that's ahead of the word that you are pronouncing. And any intermediate words must therefore be stored somewhere after you've looked at them and before you can pronounce them. This buffering only makes sense when you're dealing with sequences. There is nothing to buffer if you're processing a single word. So that's an important difference between single and multiple word processing. And finally, when the word sequences you're reading are actually sentences, you have to do a lot of other things in addition to recognizing the words, and these are things like syntactic and semantic processing, comprehension, and monitoring. So the fact that these take place while you process word sequences implies that the task of visual word recognition, that is, of recognizing individual words, is not the same as reading fluency. Reading fluency of either word lists or passages does require visual word recognition, of course, but also involves a lot more. These differences also suggest that word list fluency is not the same thing as passage reading fluency, because with the passage, you also have to process the sentences for grammar and meaning. So there are several important differences between reading isolated words and reading word sequences with or without structure and meaning that we have to take into account when we consider visual word recognition and its relationship to word reading fluency and ultimately reading comprehension, which is the goal of reading.